The Metis Tech Show.
Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
The Metis Tech Show.
So, Austin, before we started recording, you were telling me about pupusas.
Yes, my newfound love.
What is that?
So, I've never heard of it before, but pupusa, there's a Mexican restaurant down the street that has them. And on their menu, it says it's a handmade corn tortilla stuffed with chicharron and cheese served with pickled cabbage and salsa. But it's like a baked cake, and it's delicious.
Yeah,
You had me sold at cake.
What about you? Scott?
It's funny because I'm a big Mexican food, especially from being from California. Is that where's that? Is that a
according to the Google, it looks like it originates out of El Salvador. But I take it that a lot of Spanish restaurants would put their own spin on it. So there's different types of pupusas, but the one down the street is pretty good. I plan on trying them everywhere I can now that I know they exist.
Yeah, I'm gonna have to look out for that. Yeah, me from California, I'm a big fan of California burrito. Just it's simple, but so burritos in California, they're the size of your wrist.
Oh wow.
Yeah, and so you have carne asada, just your meat and cheese, lettuce. If you like sour cream, and then rice, and then actually French fries, believe it or not, in the burrito. Yeah, so it's a pretty massive burrito. But like anything, I tell people back home when they go visit to California, they always ask me, Scott, what is the place to eat at? What's the Mexican joint? And I always explain. I tell everyone this. I was like, guys, if you look at outside, if it doesn't look, it looks not. I don't want to say it looks dumpy or anything like that, but if it looks not uptight and clean, go to that spot because that's the true where the true Mexican is. Right. And how I, with good Mexican or not, is when you get a burrito, they don't hand you one like little sauce packet or a sauce container. They hand you like 10. Because what you do is you take a bite, take a little sauce and put it in your bite and eat, and keep every bite you add more salsa to it. So yeah,
I'd be down with that. I like sauce.
Yeah.
Now, Scott, do you put beans in your burritos?
Hell no. No, sorry, shouldn't say that. No, I do not like beans.
Yeah. I feel like
beans at all?
No, I don't like the word bean. Pinto, black, no, none. Zip.
Beans are great.
No, I can get away with refried beans, but I mean, if I have to, but that's still not my favorite.
Yeah,
I just won't eat them.
I'm with you. I'm not a huge bean eater, but I do remember a couple episodes ago you were mentioning your disdain for beans. Yeah, when I do Mexican or Spanish food, I will usually just do the classic, like a fajita or tacos. But every once in a while I'll spice it up. I've had these things called tostones, which is almost like
those are good.
I've had it once. It was like a hot pocket of like Mexican filling, and it was so good.
Yeah,
somebody made them from scratch for me, and they were phenomenal. But typically if I go to a restaurant, I'm just going to keep it simple with the fajitas.
Nice.
Yeah. So welcome to the Metis Tech Show. I'm here with Austin Blume and Scott Tallman. My name is Bryn Raptor. Austin, introduce yourself. Let us know what you do for Mitsubishi.
So I've been with Mitsubishi for 12 and a half years, going on 13 in August. Currently a control specialist, tech support. But I've done training, I've done other things. So I just essentially not just controls, but basically take the whole gamut of all the calls we get. Just controls is on the top of the end as far as the skill goes. So
cool. Now we're here today. You actually came to us with the idea for this podcast, which is just common TSA calls. So this will likely be a two-parter because we've got our city multi TSA calls, we've got our M&P residential TSA calls, and it's just a lot. We have a lot of variety when it comes to that stuff. So we'll probably
Mm-hmm.
start with the City Multi today. What would you say is the most common TSA call?
Believe it or not, I think the most common call for City Multi would be charge related issues,
Okay.
generally in the area of performance.
Gotcha. So you get the call, system's been running for a while, or is this new install? And then
Generally not a new install when it comes to this type of thing, maybe 6 months to 10 years down the road. But usually new install is pretty well done just because of the fact that the distributors are pretty involved with the City Multi product, the DSG members. So the installers know what their additional charge is. And generally, there's somebody who's checking on all that stuff, checking on along the way on the job just to make sure everything's being done properly. So new installs generally aren't that big of a deal with charge. Maybe once or twice where we've had some contractors who were unaware they had to add additional charge, but pretty rare.
Okay.
So now this is later on down the road.
Gotcha. So typically this is going to be from something like a leak developing at some point.
Yeah, I think so. It's kind of weird. So in the past, we used to sell branch controllers that had flare fittings.
There's nothing wrong with flares.
There's not until you try to get an installer to do 32 flares.
Oh, I know. I get it. I was just making a joke on that, but yeah, I get it.
Yeah. So, I mean, yeah, you got 32 times and one of them may be, it's hard to get them all right. No matter how good you are. But yeah, the branch box was a big one with the flare fittings. And then a lot of contractors didn't know you needed to add some refrigerant oil to the flare to keep it from backseating.
That's the biggest issue that we see. Exactly right there. Yep.
Mm-hmm. Yep.
Yeah,
So
that makes
that's a
sense.
huge one. We've actually had that one here in Atlanta in our office. I think about a year after we moved into the building, there was one of the systems had lost about 20 pounds of charge.
Oh, wow.
And that's what they found was it was leaking from a few of the flares. And I guess we've got 13 systems in our facility in Atlanta. So I guess whoever did the flares on that one particular branch box just forgot the oil.
Yeah.
So
it does make a huge difference, just, getting that proper seal and everything. So as far as when you get that TSA call, how do you determine, okay, it's time we should maybe take a look at the charge based on the symptoms? What kind of drives you to go, okay, it's time to consider this as a charge issue?
So typically I try to get as much information out of the technician as possible. Like number one, does he have everything inside cranked all the way down to the lowest, assuming we're in cooling mode, cranked all the way down to the lowest set point with a high fan speed. If he does, and we're still not keeping space temperature, I like to pay attention to what the outdoor unit's doing. So you could have a single chassis system or a twin system together. So it really depends. On a low on charge scenario, if you have a twin system, there is a very high likelihood that only one of those condensers is going to be running. And that has everything to do with the target low side saturation target, essentially. So on maintenance tool, it would be TE, because TE is what drives compressor frequency. So anything higher than 32 degrees, which is 32 is the target, but anything higher than that's going to basically drive the compressor frequency on that particular outdoor unit up. And if it still can't keep what it needs to, then it'll bring on the second condenser. But if we're low on charge and our TE is already low or at 32, then it's not going to see a need to bring compressor frequency up or even bring on the second condenser. So another one would be fan speeds on the outdoor unit. If it's 85 degrees outside, there's no reason for your condenser fans to be running at a pretty low pace. I mean, not unless you've only got one or two indoor heads calling, but if you've got everything calling, then we should have full demand, full capacity, and we should be trying to keep the head pressure on target. Head pressure targets are another thing. So generally our head pressure target is 18 degrees above ambient, or no less than 100 degrees during any given situation. So this is where head pressure targets are going to be managed based off of coil segmentation and fan speed or fan frequency.
Yeah, and to be clear, when we talk about head pressure, a lot of what we do, whether it's high or low side pressure, when it comes to the City Multi, is really a TC and TE target. It's a saturation point of those pressures.
It is.
And that's really the main driver. And that's one of the huge benefits of Maintenance Tool with the commercial equipment is how much information is available for diagnosing something like a low charge. So when it comes to low charge, what type of error codes will we typically see in that case if it does get to that point?
So the most common would be an 1102 discharge temperature fault.
Okay.
That would be the most common. So when I look at a charge or a system that has a potential charge issue, it usually goes in stages, right? So if it's slightly low, let's say it's missing 15 to 20% of its total charge. Mm-hmm. Usually this is where your compressor temp, your TH4 temps on newer models would be starting to rise above 200 degrees, 212 degrees. And then I think an 1102 is going to trip out, I believe, at 248 degrees Fahrenheit. So, and before it ever does that, you would probably have hit a lot of 1202 preliminary alarms in the background that you wouldn't be able to see without Maintenance Tool or without knowing which dip switches to turn on at the condenser. So Maintenance Tool is pretty important.
Yeah, and it looks like another one you might see is 1500, which is saying a refrigerant overcharge.
That's a fun one. So on a 1500, the definition for a 1500 is they label it as a refrigerant overcharge, but it has nothing to do with the system being overcharged, even though an overcharge would cause this particular error code. But what they do is they take on newer models, you've got two possibilities that can give you a 1500. First possibility is if you take your compressor discharge temp, which is TH4, and you subtract your high side saturation temp, which on Maintenance Tool would be TC. If those two items get within 18 degrees, then you're going to hit a 1500. So we would call that discharge superheat. So discharge superheat, typically the range is 20 degrees to 90 degrees. 20 degrees is not good because you're flooding the compressor. And then 90 degrees on the other end of the spectrum is not good because you're starving the compressor.
Right.
The other possibility for 1500 would be they would take the compressor shell, bottom shell temperature, and subtract it from the TE, which is the low side saturation temp. And if that gets within 18 degrees, same target range, 20 to 90, but if that gets within 18 degrees, then that's going to be a 1500 as well. Now, why would you flood the compressor in a situation where you're undercharged? A lot of that has to do with the way the system operates. So, like I said, you're in that 15 to 20% of lost charge scenario. Your compressor temp starts to rise. Well, the system knows it's starting to rise, so it's going to try to avoid that at all costs. And when it does that, it might start diverting liquid from other places within the system. If it's a heat recovery system, so the branch controller may open up LEV3 more. Or if it's a Y series, it may start taking the expansion valves at the indoor units and starting to raise them slightly. So we're not totally passing, we're not absorbing a whole lot of heat from inside space or whatever, but we're just passing liquid, maybe even flooding through some of those coils back out to the outdoor unit, which over time can end up stacking refrigerant in the accumulator to the point where it goes over the crest tube and the accumulator, and we end up getting a 1500 potentially on a low charge scenario.
Yeah, so just some of that logic. And as far as I'm concerned, whenever I watch Maintenance Tool and, we can simulate some things in the commercial room, there's a lot that goes into protecting that compressor. And I think that is kind of what you're describing there, is that once the compressor is maybe starting to struggle with its compressor discharge, we're going to start to do some other things to try to keep that compressor protected, whether it's bypassing or trying to cool it down, trying to pull liquid back to try to maintain the integrity of the compressor. So that does actually kind of make sense. And it looks like another thing that could cause either of those error codes is if there was a malfunction of LEV5A or B. So how does that happen?
Yeah.
Why is that so common?
All right. So if you're familiar with if you're familiar with any of our expansion valves, we have two different types of expansion valves. We have the screw-on type, which basically is a gear-driven expansion valve coil that screws onto a valve body. And then the coil will drive a pin in the downward position to create a more open expansion valve, or release up to create a closed expansion valve, or vice versa. And essentially, that's one way to do it. The other way is what I would call an electromagnetic expansion valve, which is just a coil that sits on top of a valve body, and inside that coil there's 4 coils that get 12 volts DC pulsed to them, either in a clockwise or counterclockwise scenario, and each pass creates a magnetic field that drives a screw inside of the valve body that would either drive open or close.
Wow, okay. So when it comes to LEV5A and 5B, is that something where they malfunction, or?
Yeah, typically all it is a bad coil. But the scenario for that would be all of our units. Let's just take a R2 system that has, let's say it's 120,000 BTUs, and let's say it's a K model, because that's where LEV5A, 5B are. I know we have new models out that use different methods, but there's a ton of these K models out there. So some of these techs are going to come across quite a few of these. Yep. But essentially what happens is, if you were to look at a refrigerant flow diagram, the system is broken up into 3 coil segments. So underneath the right side of the system, so if you were looking at the outdoor unit head on, underneath the right condenser fan motor, that entire right side heat exchanger is its own coil segment, and it is controlled by solenoid valve SV4C. All right, on the left side of the outdoor unit, underneath the left fan motor, you have a top coil segment that's controlled by SV4A, and then a bottom coil segment that's controlled by SV4B. Now, I might get those wrong. Maybe A's on bottom, B's on top. I don't really remember off the top of my head. But that's essentially kind of the different coil segments and how we get refrigerant to them. And so the system decides how many coil segments it's going to be using. So on an 85-degree day with everything calling, it's going to need all the heat exchanger. But if it's a 60-degree day and you've only got 20% of your indoor units calling, it may decide to segment some of those coils in order to, for number one, for efficiency, number two, to manage head pressure, because along with the fan speed of the condenser, is going to be how it's going to manage that target head pressure, which is remember, it's 18 degrees above ambient, but no less than 100 degrees. And during those segmented portions of operation might be when we utilize LEV5A and 5B. So, for example, in the event that it's kind of cool outside and we need to segment off the right side of the heat exchanger for capacity or performance or whatever, or we just don't have a big load, SV4C will de-energize closed. And then LEV5B, which is actually what goes to that side of the unit, would open up slightly because there's a lot of refrigerant sitting in that right side of the heat exchanger. So in order to get it back into the system, it opens up generally to 200 to 400 pulses, and it's going to allow a path for all that liquid that may be stuck in that condenser coil to boil off and make its way back to, if you follow the path, it's actually just a shot right into the suction, right back to the accumulator. Right? It's not a whole lot at once, so it's not like we're trying to dump liquid into the system or anything like that. But in the event that let's say one of those gets stuck wide open, for example, if you as a tech show up on an 85-degree day and everything's running perfectly fine, but then the complaint is every night this thing trips on an 1102 alarm, which is compressor discharge temperature. There's got to be a reason why it's only happening at nighttime. And usually nighttime would be when you start to segment condenser coils due to capacity.
Mm-hmm.
So if LEV5B is stuck wide open, you could actually start to get hot gas bleed through and go right back to the suction line. And I've seen it to where on most of our outdoor units, there is a TH5 thermistor, which is your accumulator suction pipe temperature. But I've seen it sometimes, if it runs long enough, that TH5 temperature can be almost as hot as the compressor temperature, just because of the amount of hot gases bypassing through it.
Oh, wow.
And then eventually you just end up overheating the compressor. So different scenarios, could cause that to happen. Same thing with LEV5A. It really just depends on which coil segment's being utilized or not utilized.
Yeah, so that's with the K-gen, and now with the N-gen, we switched from those solenoid valves over to reversing valves, but the theory stays the same, right? We have an LEV that kind of works on one side of our heat exchanger, works in concert with, a solenoid valve with our K-gen. With our N-gen, it's a reversing valve, just allowing to drain off that portion of the coil when we don't need it. Again,
would that be LEV A, 2A, 2B, and 2D?
Yes.
2A and 2B, and then 2D is kind of like a bypass.
Oh, that's the bypass. That's right. Yep, that's bypass. Yeah. I'm thinking 2A and 2B. Yep.
So 2A, 2B, and then our larger units, we actually have another reversing valve, so we get an LEV2C just because of the increased amount of coil segments. LEV2B, I always, could equate that to an adjustable valve. It's just essentially allowing more or less refrigerant to bypass that coil when we're in mixed modes.
Yep.
Yeah.
So, that makes sense. Again, with LEVs, if they're not metering properly, you're going to start to flood some things, or you could actually starve portions of the system. So that would make sense. So, what other ones would you like to discuss? What else are you getting pretty frequently on the TSA side?
All right. So electrical troubleshooting is actually a pretty big one. And that could be anything from communication errors. So comm faults are probably the biggest biggest call that we get. So I guess we can talk about
comm fault you see.
So typically the biggest comm fault we see is generally a comm fault is going to be either a 6607 error, what generally is a 6607 error code. But it really depends on where you are seeing the comm fault, because there's a bunch of different situations. But 6607 just means no acknowledgement, right?
Yep.
Yeah.
So on a 6607 fault, is it at the central controller, right? If it is, and it's showing for 3, 4, 10, 12, 18 in their units, however many it's showing for, well, all that means is that central controller cannot talk to those indoor units. So I guess the next point would be, can those indoor units operate? Right. So if those indoor units are operating with no issues other than maybe showing a 6607 with no address associated with it, that would be a situation where for some reason the central controller is having a hard time talking through the TB7 comm, through TB3 at the outdoor unit, all the way down to those particular indoor units. So generally, if the central controller can't talk to anything inside, the system will run, but the indoor units may throw a 6607 on the operation screen. So it'll still say cool, heat, whatever, set point, but you won't actually have an address associated with it. On the other hand, if you have an indoor unit that says 6607 and it actually has, let's say, address 51 or 65 or whatever outdoor address it is, that's a bad comm fault, because that means that particular indoor unit cannot actually talk to that outdoor unit. And all this has to do with two different comm voltages. So TB7 on each outdoor unit is reserved for the central controller, and out of the box, the default 24 volts DC is going to come from that central controller. So TB7 by itself has no voltage on it, right? So if you get to the outdoor unit and you got 0 volts on TB7 outside, but you do at the central controller inside, obviously we got a wiring issue.
Yeah.
Whereas TB3 produces DC voltage at the outdoor unit for all the indoor units. So the scenario would be the indoor units have a 66 or 7 saying they can't talk to the outdoor condenser 51. Do you have any voltage on TB7 or TB3? If you do, does that voltage at least make its way all the way to that indoor unit? If it doesn't, that would make sense. We got a broken wire or something like that. But if you show up and you got no DC voltage on TB3, then that's a totally different scenario, which it could be an outdoor board. Or the fun thing that low voltage DC likes to do is if you get a ground on DC voltage, it shorts the ground and it actually shunts the DC voltage to ground, which makes it look like 0 when you check it on your meter. But if you isolate that, so kill the power, take your wires off TB3, turn the power back on, do you regain your 29 volts DC? Which, if you do, everything's fine outside, but now you got to go on a witch hunt looking for the COM fault.
For that one, Austin, that's a fault that I'm sure we all do, right? Switch TB3 and TB7 in our training rooms.
Oh yeah.
So they get the hard one right because TB3 it reads 0, and TB3 reads 24 and TB7 reads 0. So they still can't get in their head. So I tell them, take it off the line, just measure. If you're reading 24, then we know that's coming from the AE200 that goes on TB7. Isolate it. Then measure TB3. If it's no wires, if it's reading 29, at that point it's not a board problem. It is a wire problem. That's kind of how I kind of go through it.
Yeah,
so I get it.
Scott, that's probably one of the biggest startup calls we get is those two swapped. Yeah. And like you said, the easiest thing to do is kill the power to the condenser and see which terminal block still has voltage on it.
Yep.
Yeah.
Only one of them should, and it should only be TB7.
Right.
So.
Yeah.
That means if TB7 does have power, they put CN41 on to have that jumper.
Well.
Yeah.
Which that leads to other things.
Yeah, I've actually done something similar where I will short MNet. So I'll jump across M1, M2 with a jumper. And they have 0 volts at TB3 at the outdoor. And I say, okay, is it a short in MNet? And they go, I'm not sure. I go, do you want to go look or should we just power down, take our wires off TB3, restore power, and see if the voltage came back? If it came back, we got a short, right? Other times we can have a bad power supply board. And that's that's what's preventing, our voltage to TB3 in the first place. So we kind of have, it just splits up where that, issue lies. Is it an outdoor unit problem or indoor unit problem?
Absolutely.
Or wiring
And I think
problem?
the biggest thing with electrical troubleshooting would be isolation.
Mm-hmm.
So knowing what you should have for voltage, where it's coming from, where it should be going, and then isolating those components to figure out without the in-between, is everything still good?
Right, yeah. Where do I lose my power? Where does it stop?
Yeah.
So going along with those COM faults, 7102, this one is one that I have when I was in a van dealt with quite a bit. And then even when we do some installation with some of our new equipment that's come out, have bumped into during installation. And as far as I've been told by Rick Powell, who I'm sure you're familiar with, he had mentioned that oftentimes a 7102, despite that it gives multiple reasons, typically it's because it can't see a branch controller. Now, there's a way you can speak to that, but...
Yeah, so 7102 would be another good one. So let's take that instance where your indoor units have a 6607. They can't talk to the outdoor unit, but then you walk up to the outdoor unit and it has a 7102 on the outdoor unit. So I generally think of a 7102 as a COM fault. Mm-hmm. There are other reasons it could happen, but a 7102 in most aspects is going to be a COM fault. And what that means is that you may have 29 volts DC outside, but for whatever reason, it's not making it to the indoor units, or at least to a branch controller, or something is going on there where it can't see it. Now, if you look in the book, there are some other reasons, and these have come before, but 7102 is basically the outdoor unit sees too many indoor units, which unless I don't think I've ever had anybody with too many indoor units. I mean, because you could put a large amount of indoor units on these outdoor units, right? But it sees too many indoor units, or it sees 0 indoor units. So there's your COM fault, right? So it either sees too many or 0. It doesn't see a branch controller, that's the big one, right? So we've actually had unfortunately, we've had a lot of people doing startups where they have a PURY, heat recovery outdoor unit, but their distributor sold it as a PUHY,
Oh goodness.
non-branch box. And they got a whole building, 20, 25 outdoor units with no branch boxes on them, and they're all the same models. So that's a
Ouch.
big headache. Yeah, that's I don't know who's paying for that one, but
Yeah, and to clarify, PUHY is our Y series, where there is no branch controller, no mixed modes, no heat recovery, so typically no issue. But once you put an R2 outdoor unit on there, it needs a branch controller.
Yeah, absolutely. And then, believe it or not, the other one, which is kind of odd, but on every outdoor unit, every single 3-phase city multi-outdoor unit that is K-Gen and above, SW5 number 7 has to be in the on position.
On position, yep.
Yeah. Now that actually changed a little bit on our newer stuff, the N-Gen. So you got the standard stuff, let's say like a P120, but you can also have an EP120. And if that's the case, you got to have 7 and 8 in the on position.
Yep.
But if those aren't right, which sometimes, you get maintenance guys who, when they're putting the covers back on, their screwdriver slips and, it hits a dip switch, and then that doesn't take effect until the next time the unit loses power.
Mm-hmm.
Right. So I've seen before where they're like, hey, man, first thing I do always check is dip switches, because you never know. Right. So I had a guy we started this unit up 6 years ago, never had a problem, but now we have a 7102. Sure enough, the dip switch was wrong, but nobody's been there to mess with it. So the only assumption could be that on startup, this thing was running fine. Somebody accidentally threw the dip switch in the off position, and this building just never lost power for 6 years until they did. Now, when it came back up, now you've got the error code because it doesn't think it's the right outdoor unit.
Oh,
so,
yeah.
Well, in that case, that also can be for that particular bug. For that issue, if it's a EP model, right, the 5-8 being on, it will be stuck in scroll too as well. Because that's I
remember,
happens.
yeah,
That can happen too. So when
that can happen.
Stuck in scroll is, if you guys don't know, listening in is, when you start up our outdoor units, we show the refrigerant, so 410, the firmware that it's on, the unit outdoor address, and the fourth one is the horsepower rating, Austin.
Yeah, the horsepower rating. Yeah.
Yeah, what it is. And stuck in scroll, it'll just continue to be in that menu over and over and over. So I have experienced that one before, Austin, and I do this particular bug in class more and more just now because of our new A1 generations. We no longer offer the P series. Now it's just the EP and the hyperheats. So I bring it up because if they ever have to do a board replacement, they have to pay attention to that particular dip switch.
Absolutely. Yep. And then the last thing, this is the worst almost worst gut wrenching thing that can happen on a startup with a 7102 is you don't have the right size branch controller. So, like, if you were to look at our branch controllers, there's 2 different kinds. So, 3 different kinds really. You have the J1s, right? And then you have the JA and the KA. So a J1 is a single branch controller. Yeah. It's only good for up to 126,000 BTUs, right? And then you've got the JA and KA. The JA is much higher, and then the KA is even higher than that. I don't remember off the top of my head what the new ones are. I know the old GA and HA ones, one went up to 240,000 BTUs. The other one went up to like 336,000 BTUs. But if you got a big job site and you're doing a startup and you've got this one section where all your equipment's sitting on the side of the job site, be very careful, because a lot of those branch boxes look exactly the same. So you might have a small 72,000 BTU outdoor unit somewhere, and it only needs a single branch box, a J1, a dash J1. But what if that gets put on a bigger system And then the smaller unit gets the H or the JA or KA branch box, which it'll work with that, but the bigger one won't work with the smaller branch box.
Oh, okay.
So that'll give you a 7102. That one's kind of bad because that means everything's already piped in, charge is already released, and there's no easy way to fix that other than replacing the branch controller.
Yeah, right when you were about to start it up too. That's the worst. You just flip the disconnect. You're finally going into test run. You're going to do your hour of runtime. You get your 7102. So moving past the communication faults, let's talk about thermistors. So issues with thermistors. I'm sure you get a lot of calls with them.
Yes.
Which ones are what are you normally finding with that? Are you getting error codes, or is it normally just something reading out of range? Or
reading out of range? It's I'd say that 80. If I had to throw a number on it, 85% of bad thermistors are going to read out of range long before they ever actually give you a thermistor fault. Especially with City Multi, and the reason is on City Multi we can see that stuff.
Yeah.
Residential, I'm pretty sure it's doing the same thing. We just never have a laptop hooked up to it typically to look at that stuff. But the most common thermistors on anything we have is I'm going to say is on a branch controller, and it's going to be the TH15 or TH12 thermistor in the branch controller.
Okay. And
that has to do with where they're sitting, which is on not so much on the newer branch controllers, but on the previous gen branch controllers, which there's thousands of them out there. But they're basically sitting almost in the drain pan on the pipes. So you get a little bit of water standing over like 5-10 years period where you get a little bit of sludge in the drain line. So now you got some sitting water. It's not enough to overflow anything. It still drains, but it's enough to start to corrode those thermistors. In maintenance tool, it would be the T5 and T2 thermistors, but in reality, it's TH15, TH12.
Right.
Interesting.
Yeah.
So the nice thing, again, we've mentioned it already, but with maintenance tool, these things are a lot easier to identify. Typically, I've always talked to in class, I explain if you get on the phone with TSA, they may want to see maintenance tool files or data while the system's not even running. And that could just be, that could just be to take a look at those thermistors, take a look at standing pressures, but to see if any of those thermistors are reading out of that ambient temperature, or room temperature. If it's, 10, 15 degrees, everything says 72 degrees, and you've got that one thermistor reading, 92. Well, why don't we go take a look? Let's ohm that out, see what's going on there.
Yep. And that's typically what we would recommend is, if you're having concerns, if you can, if you're at a facility where you can do this, stop all the units and just let it sit for 10 or 15 minutes. I know that's kind of hard to do at nursing homes and things like that, but just looking at those standing temperature ranges, they should all be pretty equal, other than the compressor discharge temperature thermistor. That's usually 30 or 40 degrees higher than the ambient, but other than that, they should all be pretty standard with ambient temperature. Now, the nice thing, so all you techs, get something to write with. This is the best advice I can give you. Part number R610602200 is a part number for a thermistor, basically, that you could splice in, and it's good for any thermistor in the outdoor unit, any thermistor in the branch controller, any thermistor at an indoor unit. And the reason I give you this part number is because these are basically branch controller thermistors, but they're all the same value. So keep a few of these on your truck. So if you ever do come across a bad TH6 in an outdoor unit, you've got one. The only one it will not work with is the compressor discharge temperature thermistor.
That's the one
I was going to ask that. I was like,
that one's the only one it won't work with. But everything else, and it doesn't matter what generation unit.
I was also going to ask, are we talking K or N? So it doesn't matter.
It doesn't matter if you have a TGMU, a TJMU, TH, TK, TL. They're all the same value all the way back, even to the R22 stuff. So,
and look at you, learn something new today.
Yeah,
these are great thermistors, and we always have these in stock. And the reason I say write that one down is because having a few extra of those on your van will get the facility up and running until you can order the right one, because there's a lot of the times on some of this newer stuff where you got to order a thermistor, and because it comes with a specific harness. You've got to wait for your supply house to actually order that, because it's not a common thing. They may not have to go through a whole lot, so they've got to order it from Atlanta. We're going to have it, but then it really depends on, did they order it overnight? Probably not. They're probably going to wait for the truck to come. So you're waiting a week or two to get this part, when if you got these extra ones, you can at least splice them in, get the customer running until you
just get running
right
until
part.
you actually get the true replacement. Okay.
Yep, absolutely.
Like
or if you do a butt splice, it could even be a permanent connection. I wouldn't recommend leaving wire nuts there except for temporarily, but if you make a permanent connection, you can, solder, heat shrink would even be better.
Yeah, I actually had a contractor not too long ago, and he had a TH6 on a K-Gen that had gone bad, and he ordered, and he showed me the part, and it had the exposed wire on the end of it. It had already been stripped back. Yeah. He's like, what am I supposed to do with this? I'm like, put it in. Like, that's where your job is done. You just got to make the connection. He's like, well, typically, I'm worried about the harness and the connector. And I was, happy that he was at least concerned of how, potentially a wire nut could change that resistance value. So he was being conscious, which was great. But it was also nice to be like, yeah, this will work. Go ahead. You're good to go.
Yep.
So.
And if you're in a situation today or tomorrow and you don't have those extra thermistors on hand, and you've got a thermistor, let's say in a branch controller or even in an outdoor unit that's taken the whole system down, go steal one from an indoor unit, coil sensor from an indoor unit. It's better to have one down indoor unit than the whole system down.
Yeah, that's a good point.
Yep.
You're already going to replace that part regardless, so you might as well just get them up and running.
Might as well.
Order. Yep.
Yeah.
Good point.
We talked about this a little bit in our Thermistors podcast, but another thing to just pay attention to with any of these things is, especially if you're getting an OL reading or a maintenance tool, it might say 99.99, is to check the voltage coming into that thermistor. Make sure that the pins that thermistor is hooked to, there is a low voltage DC signal. That's how we are able to get that resistance reading. So that's another thing to verify, especially if you're getting that OL or really high reading.
Yep. And then this one I have off the top of my head, but all those thermistors, 86 degrees or 4.3 kilo ohms, at 50 degrees or 9.6 kilo ohms. Random knowledge, but that's just in my head.
Yeah, so. Austin, you don't deal with that a lot. You just happen to know that.
Yeah. The only one I got for you is half a meg on a discharge thermistor, about 45 degrees.
Yeah. Yep.
So a little different there. So anything else you want to cover with the City Multi? Anything else? I know we kind of generated a list. What are some other, or maybe one more really common issue you see on the commercial side?
One that'll throw a tech for a loop, and it's the simplest one, but a drain fault. Believe it or not. So this could be a 2502 or a 2503 drain fault. So 2502 is generally going to be associated with an indoor unit that has a pump in it. And then with a float switch, and then a 2503 would be a system that has a pump, but maybe it has a drain sensor instead of a float switch. That's almost how they differentiate between the two error codes. But not the drain fault itself. Most technicians, if they know it's a drain fault, they can accomplish what they need to accomplish. They can get the thing back up and running again. The problem with our system is if you don't pay attention, you could be working on the wrong unit for a pretty long time, and then calling tech support, and then us telling you're working on the wrong unit for a very long time. So on our system, let's say you got 10 indoor units and you got a 2502 drain fault. Well, that 2502 drain fault will last on that indoor unit for 30 minutes. And then I have seen it last up to an hour. So my guess is there's some firmware stuff that some firmwares make it 30 minutes, some firmwares make it an hour. But either way, whether it's 30 minutes or an hour, after that time frame expires, the whole system shuts down on a 2502. And so on every single controller in the space, and I say controllers, but any Mitsubishi wired quote unquote thermostats, but the controllers, anything that shows a 2502 will also show you what address you need to be looking at. So a lot of guys will walk into a space, they see a 2502 on the stat controller, I say stat because most of these techs are thinking stats in their heads. So, but in reality, it's a controller.
We deal with the same thing, Austin.
Yeah. But they'll see that error code and they'll assume that error code goes to the indoor unit right above their head.
Oh, okay.
Problem is you've got to look at the address and see, okay, so it's a 2502 on address 4. All right. Well, what's right above my head? Maybe that's address 10. Maybe that's address 3. So a lot of techs end up working on the wrong unit. And it just totally throws them off. And then the other thing is to get rid of this error code, it's kind of difficult if you don't do it in the right order. But essentially, if you've got a whole system shut down on a 2502 drain fault, you have to find the unit in question, kill the power to that indoor unit, and then go cycle power to the outdoor unit for at least 3 to 5 minutes. Okay. If you do that, turn the power back on, everything else in the system will come up and run, and that'll give you some time to work on your drain fault. Otherwise, it's, if you don't cycle power to the indoor unit, or even if you do cycle power, but you don't get rid of the drain fault first, it's going to just error back out. So the best thing is to find the indoor unit in question, kill the power to that particular indoor unit, and then do the outdoor power cycle to get rid of the fault.
Yeah, that'll just buy you the time and not have the whole system down while you're, making your repair.
Exactly.
Which, I mean, we've discussed on this podcast and we do in class ad nauseum about just power up sequence and how things like that, can have an effect. If you make any changes to an indoor unit, there's a power up sequence involved with making sure the outdoor unit sees that change. If we're talking about, address or branch number settings, it can't it's not as simple as switch the dial and move on. There is a power up sequence and, that definitely plays a role. Now, when it comes to, let's say a 2502, which, in the book we'll say a drain pump fault, or maybe it's a 2503 drain sensor, what's typically causing that? Now, is it actually a trip sensor or?
Yeah. A lot of times it's a trip sensor. So you'll probably find water in the drain pan. Now, believe it or not, there are quite a few cases where the techs find no water in the drain pan. And at the end of the day, my first go-to is to always check dip switches. And the reason I say that is because, this thing's been installed for 6 years, but that doesn't mean that during maintenance at some point somebody didn't accidentally hit a dip switch. And then the first time this indoor unit took a power cycle, now it sees itself as a different unit. So a simple dip switch can change it from looking from a float switch to a drain sensor. And obviously, if this unit doesn't have a drain sensor, you're going to get a 2503, or if it is a drain sensor type of unit, but it switches to thinking it needs to see a float switch, and obviously this unit doesn't have one, you're going to get a 2502. It happens quite a bit.
Yeah, I could see that. Well, I think that's a good stopping point for this part. Like I said, this is probably going to be a multi-part. I mean, you are probably fielding calls on the regular, and they become more common the more you do it. So I think today, we covered a lot of the really big ones, which is great. And I think we can come back and probably do a little series just about what you guys are seeing over on the TSA side, which I think would be really helpful for our contractors listening.
Yeah.
So, that's a good place to stop. The only question I have is, so if I come back down to Sewanee to visit, where can I go and get the best pupusas?
You know what? I'm only familiar at this moment just because I did recently find the pupusas. So on the west side of Atlanta, there's a Mexican restaurant here called El Coyote, and a little far drive from Sewanee, but I'm going to try to find some up that way to see if I can't find some.
Yeah, nice. We're going to have to find them. I mean, as much as I love Tequila Mama, I also like to switch things up. And I think if I...
Yeah, we got to switch it up.
If I go there, if I go to it's what that other place is, I forget the name
El
of it.
Dorado's.
El Dorado, thank you. I'm going to be too tempted to get the molcajete, and I won't try anything new. So
have you had that, Austin?
Variety.
I know, but I've seen pictures. It looks really amazing.
Looks like a heart attack in a bowl.
Yep.
In a lava bowl.